Right, so we'll go ahead and get started. I'm going to do some housekeeping items first for the first minute or so while people are still coming in. As I mentioned just a few moments ago, this will be recorded and we will share the recording with you through the email that you've registered for the webinar with. If you registered it with a not real email or something like that, you can find it at our website as well, traefik.io. We'll post it there in addition to emailing it to you. And anytime you're free to answer or ask any questions in the Q&A or in the chat. And there'll be about 20 minutes at the end if we have some questions where I'll take those and I'll be able to answer those for you. So if you think of something during the presentation, feel free to just bang on the keyboard so you don't forget, and we'll get to it at the end of the presentation. One last thing, this is being recorded, just throwing it out there for disclaimers. So anything you say in the chat, and I may read back, and it'll be on public record forever. So just something to be aware of. All right, with that, let's get started.
Hey everyone, thanks for hanging out and taking the time to come see this talk. Today I'll be talking about the new middleware plugin system that arrived with the release of Traefik 2.3. And before we get started, just so you know that a copy of this slide deck is available at the link here on this slide. I'll also paste this into the chat window so you can follow along with the slides. There's also links and resources included at the end of this presentation for those of you who are also interested in learning more about some of the topics I'll be covering today. So just to share a little bit about myself, my name is Kevin, and I work for Traefik Labs, the creators and maintainers of Traefik, Traefik Mesh, and Yagi. I'm also an organizer of Cloud Native Nashville and DevOps Days here in Nashville, and have spoken on topics such as observability, DevOps, and software development a few times over the past couple years. And I've done a number of workshops on monitoring and distributed tracing as well. I'm an avid cyclist, and I enjoy an occasional impromptu hike every now and again. I'm also the co-founder and principal SRE consultant for Single Music, which is a digital music and live stream provider based here in Nashville that we started in 2016. You can read more about Single Music and our journey to Cloud Native on the CNCF blog that I wrote and published last month. And I've included a link to that as well at the end of this presentation. So as I mentioned at the opening of this talk, I'll be covering the new middleware plugin system that arrived with the release of Traefik 2.3. This includes topics, covering topics such as what is Traefik middleware, why we built a plugin engine for Traefik, how we pulled it off, and finally I'll walk through the development, publishing, and deployment of a plugin that I'll be writing here with you in real time. So before we get started on the writing of the plugin, I'd like to take a moment to explain what middleware is for those who may use Traefik but haven't used middleware before. Well, I'm sure most of you here already know what it is. Discussing the new plugin system without context of what middleware is would probably be confusing. Middleware is attached to the routers, which is part of Traefik that initially processes a request. It matches the rules and then it delivers that request downstream to the service that was assigned to that route. Now, prior to delivering the request and waiting on the response, Traefik is able to pass that request through multiple pieces of middleware that allows for all kinds of things, tweaking of the request, changing certain aspects of it, adding, removing headers, handling authentication. And these things are all handled before the request is sent to the service or before the service or before Traefik responds to the client with the response from the service. So there are several middlewares already available in Traefik. You can find all of those in our documentation, but just some examples of that. We have some that can modify the request, respond with a certain error code. It can manipulate the headers, add or remove headers, And some are even in charge of things like redirections, authentication, rate limiting, as well as handling things like ensuring that the request originates from a certain IP before letting it be sent downstream to the service. So essentially an IP allow list. Now, why we ended up building a middleware plugin engine? Well, namely, it's probably one of the more popular issues in our repository with over 59 comments and over 120 thumbs ups. But that's not the only reason. I think that there's a number of other reasons that we decided on implementing it, and that includes, I think, around 16% of all issues in our repository, in the Traefik repository, make a mention of a middleware. And there's currently over 100 open issues that includes middleware mentioned somewhere in the comment stream. Now, as a result of that, many of the issues that were opened around middleware just never got implemented. And this was either because there was just a lack of resources on the core engineering team to nurture and encourage those ideas into fruition, or that there just was a general lack of interest. This solved maybe a handful, maybe 5 or 6 people's use cases, not hundreds or thousands of people's use cases. In addition to that, there had been several proposed middlewares that had just been outright rejected because based on the proposal, it was determined that there was just going to be too much maintenance overhead or performance overhead if we decided to go forward with implementing that person's request. So as a result of that, the core open source team recognized that providing a logical extension point for end users to implement their own middleware was essential for the continued adoption and growth of Traefik as a viable software-based load balancing product. So how we did it? Well, the team looked at how they could provide this functionality, and one of the core requirements was that the user shouldn't have to build or manage their own custom binaries. That was ruled out from the beginning because ultimately, if somebody wanted to build a plugin, they could always just fork Traefik and implement it themselves as a middleware package, and that was just deemed impractical for most people. Nobody wants to maintain their own build pipeline for a proxy. That's just impractical for most organizations. So as a result of that, that really ruled out existing functionality within the Go ecosystem, such as Go plugins, because those required compile time implementations. In addition, the team looked at other options, such as WebAssembly, and it was determined there that those ecosystems are still emerging and needed additional time to mature and stabilize before we could really consider them. That being said, it may well be in the future that once WebAssembly does mature a bit, we may incorporate it as a plugin option. We don't know, but right now it just wasn't an option at the time. So the team settled on using an internal project called Yegi, which is capable of running native Go code in an interpreted fashion. This translates into the ability for users to provide Go code in a manner in which they might deliver Python or PHP code to an interpreter, which that interpreter then executes the code in a quote virtual machine. Now, Yegi, the way it operates is it exposes a simple API that can be used by Traefik internals to pass the request handlers to a user-provided package, and that would be the plugin, and that is then interpreted to provide user-delegated functionality. Now, currently, there's a couple things which are not used or exported by default. That is unsafe and syscalls. And this is to provide type safety and security. However, we're investigating the possibility of allowing users to grant the ability for the interpreter to access those APIs. As it turns out, a lot of libraries and plugin use cases require those capabilities. Now, the current version of Yagi supports Go 1.14 and 1.15 code, and the goal is to provide ongoing support for the latest 2 releases. So in the next part of this talk, I'll be building a plugin from the ground up. Knowledge of programming in Go is going to be helpful if you want to follow along, but if you're unfamiliar with the language, you should really consider brushing up on some of the basics with the Go tour before attempting to do something like this on your own. Now, this talk is going to be posted on the Traefik webpage, and you can come back at any time later and revisit this discussion and the concepts that I'll be presenting, so that later you can go through and build a plugin yourself. Now, as a final point, you absolutely do not need to know anything about Go in order to actually use plugins with Traefik today. However, if you want to build your own plugin and publish your own plugin, you'll need to understand and be able to write Go code. So there's a few requirements to develop and publish a plugin. For developers, Traefik allows for a development mode, so plugin authors can work on their plugins locally before publishing them. The prerequisites for this include having a recent version of Go installed and a configuration file for Traefik to read that configuration file includes parameters for the plugin. Now, in order to publish a plugin, the source code must be made available on a publicly hosted GitHub repository, which allows the Go module Go proxy system to securely mirror the code, and that allows for Traefik to pull that code. And the public repository on GitHub must have the Traefik-plugin topic set. I'll walk through all of this throughout the demo later. And I'll be covering what those requirements are as I develop and build the plugin here next. All right, so on to the live coding portion. So as you can see here, I have a completely empty directory. There's no files in here. So first thing that we'll want to do is download and install the Traefik binary. And I am using Linux. So just go ahead and pull that in. And we can see here that the Traefik binary is now available for us to run. And we do need to create a couple configuration files for Traefik to be able to serve a service, and also set up the plugin as well, so that Traefik knows that on the local file system that we're building a plugin for it to use. So the first thing we'll need to create is the actual configuration file for Traefik. And I will copy and paste the values here. Of course, you'll need a pilot token to register pilot, and I am configuring the dashboard so we can look at the dashboard as we run the service, and we can see it in the Traefik dashboard. I have a single entry point here, which is just a logical point for any request to come in to Traefik, and Traefik will then route it. And also I have a file provider, and let's create this file and populate it now. And within this file, I have the HTTP router, and all it is a rule that will look for /whoami on the request. And then if that matches that rule, the service will go downstream to my local server, or my local whoami container that I'm going to start here in a moment, and serve a request from that. So I do need to launch that container if it isn't running already. It is not, and I do need to start my Docker daemon. Now that that is started, I can run the whoami, and I'm attaching this to the host network and exposing port 5000, so that whenever the request is forwarded to localhost 5000, the whoami container will answer. And if I go to localhost 8000 whoami, well, it might help if I actually start Traefik first. So let's launch the Traefik service. There it is. All right, we can see that the request came into localhost port 8000, but it was served from the Docker container that I'm running here at port 5000. So you can see that the host internally, this is what the container running downstream, the who am I container service sees, is the host being localhost 5000, because that is the request being made by Traefik internally on behalf of the user. So now that that is running, we need to get our plugin set up and operational. So the first step is to create a directory for my plugin. And now that that directory is created, I just need to change directory into it. And I am using the latest version of Go 1.15. Now, if you use 1.14, you may run into some issues with Go modules. So I highly recommend using Go 1.15 because there are some bugs that they fixed. So the first thing I need to do is set up my project. And that is, the first step is to create a new Go mod file. And we can see within here, there is now a Go mod, so that whenever we want to pull in any kind of vendor dependencies, we can do so. The first step is to write the code. I'm going to create a new Go package called UID demo. And every plugin should implement these items at a bare minimum. And the config is to hold what you might think it holds. And that is primitives that need to be passed to the plugin. And these can be configured at the middleware layer declared within the Traefik plugin. You need to create a function that will create the config and return it. And this is just empty for now, but we will populate this later when we have something meaningful to put here. Right now we don't, because we're just getting things stood up. And we need a struct that will hold the necessary components that are required to instantiate a Traefik plugin. I hope if I spell struct correctly. So what we're seeing here is that we have an undeclared package. It's pretty simple to fix that. Just need to import it. And now we'll need to create a new method that has all of the prerequisites available to it as they're passed and during the instantiation. And this will return a HTTP handler and an error if there is an error. Right, it is complaining because I haven't fully implemented the spec yet. And finally, we need to create a serve HTTP method, which is passed in a response writer and a request object. And these will actually, I'll show you how these two variables function and how they behave with respect to a request. One is actually to write to the response, and the other is to manipulate the request before it is sent downstream. And again, I will show you how that works. Now, the first thing I want to do is I'm actually going to completely override the response and deliver, instead of the downstream request, which is all of this stuff here that is actually coming from the service, I'm just going to ignore all of that, and I'm going to send a hello world to the browser. Now, this isn't really practical. Like, I don't think anybody would realistically ever do something like this, but it does demonstrate how the response writer functions, in that you're able to manipulate and modify the response from the downstream service if you so wanted to. And there are some examples in the plugin repository which do this, which is there's a simple regex find and replace, essentially, is a pretty good example of something you may want to do. I mean, you could theoretically compile a template here if you wanted to. I'm not sure it would be the best idea, because you're essentially doing some kind of business logic inside of your proxy, but who knows, maybe this is just the most logical place because you're not able to modify the code downstream for whatever reason. Maybe it's some legacy service that you can't really change, but you could theoretically, in this proxy layer, manipulate and modify the response. So before we can actually execute this plugin, we need to create a Traefik.yaml file. And this file is what will configure Traefik to consume and operate this plugin. So I'm just going to copy and paste all of this. We have a display name, we have the type, middleware, and I'll explain why we have this stuff here later in the presentation. I have an import statement here, as well as a summary and some test data. And I'll explain what these things are later, but for now, just know that this file has to be here so that when Traefik launches, it can configure and execute the plugin. So in order to use this, I need to declare a development plugin in my Traefik configuration. And to do that, I just need to create an experimental dev plugin configuration, include the path, like the full path to the working directory where this is executing, and then provide it a module name, which is the full path under the source directory. So we have github.com, not sure if Kevin /UID demo. And Traefik will know that its operational go path is this current working directory, which is home/kcrawley/dev/Traefik plugin. And then because that is the go path, it will look for the plugin in source/github.com/not sure if Kevin /UID demo. Now, the last thing I have to do is I have to configure my router to use this middleware. And that is relatively straightforward. I define a middleware configuration, and I tell it to use plugin demo. And then I add the middleware to my configuration. By declaring this is a development plugin. And again, there has to be some sort of configuration here. We're going to change this later, but for now, I'm just putting in some temporary filler value. But this references the development plugin, which I referenced here. And so once we restart Traefik, we will see that oops, I need to change that to middlewares and then restart Traefik. All right, we'll see that the request actually is now being overridden by this ReadWrite modifier. So if I refresh this page, you can see hello world instead of the response headers. Again, this isn't practical, so let's actually do something that is a little more real world. But again, this just was to demonstrate to you that a little bit around the functionality of the ReadWrite handler. So the first thing I'm going to do is I'm going to create an import because I want to use a third-party library. And in order to do that, I need to import a package. So if I import this, of course, it's going to be, it can't be found because we haven't technically imported it yet to the package. We need to pull that package in. And you can see here that it is now pulled into the UID demo package. And then now we can use it. So what this will do is it'll actually create a unique ID on every request. And this could be helpful for signing a request from the load balancer and then validating that on the client and the server side. But first, let's focus on the server side. And we'll do that by injecting a header to the backend service. So on the request object, I'm going to set a new header. And I'm going to use the UID that I generated from my library. And I'm going to get rid of this because it's not practical at all. But what I will do is I will add a serve HTTP. And what this will do is pass along the request to the next middleware if there is any. And if there's not, it's going to then process the request and make the request on behalf of the client to the backend service. And the response will be handled through the response writer. And this is all done in the background. But if you want to learn more about it, you should probably poke around in the Traefik code base to learn how that works. Of course, we do have to restart Traefik because it does have to reinterpret the Go code that we're writing. If we retry the request, we can see here that the downstream service is now seeing a new header being injected into the request, and that's the UID. And if I refresh the page, I can see a new unique ID being generated every time. Now, this request isn't available to the client. So if I refresh this page, I can see here that the response headers, we don't have anything in here. Well, what if I wanted to provide that request ID to the client? And for whatever reason, maybe there's just some validation there on the client that would look at that and ensure that the backend service matched it as well. So what we need to do then is inject that header into the response. And we can do that with the response writer. So now I'm going to add that unique ID to the response writer. And I'll need to reload Traefik. And if I refresh the page here, I can see here that I got a Traefik UUID on the backend service. But in addition to that, I got one on the response from the client. So cool. All right, so for instance, now what if I wanted to be able to configure this header name? I didn't want to use Traefik UUID. What would I have to do? Well, that's where the configuration object that we set up initially comes into play. Is that we can configure this header at the router middleware layer. So let's walk through that and see what that would look like. So within my UID demo package, I'm going to create a default header name. And we'll just set that to what we've been using, which is Traefik UUID. And now within that create config and the config, I need to add a header name property. And within my create config method, I want to add a default response, which will use that default header. And now within the UID demo structure, I need to add a header name, and we will reference this during the instantiation of that object. Just so we pass golint, I just tab those over. And I'll do the same thing here. I'll add header name to the returned handler. And again, just so that we are compliant with lint, that will work. Now, what would happen if for whatever reason the user passed a blank header name? We don't necessarily want to allow that to happen, so we're going to put an error check in here, and that would prevent anybody from passing an empty header. So if the length of the header name is 0, we don't return a UID demo object, and we return an error instead. And then below down here, I will reference that new property that we added to the UID demo and use that instead of the string reference that we had in there before. So let's take a look at what would happen if for any reason we decided to set that empty. So in order to configure that, I will change foo bar here to header name, and I'm just going to reference an empty string. And if I try to start Traefik with that, it failed. It gave us that error. It said header name cannot be empty. So let's actually put something that makes sense here. All right, so now that that is correct, if I refresh the page here, we can see that the header actually changed. And now that is configurable. Great. All right, so for the next part, I'm going to be playing back a recorded video because it takes around 5 to 10 minutes for a plugin to populate, and it didn't make sense to make y'all wait here. So I will play back that video, and we'll come back here and use the newly published plugin in our project instead of the one that we've been working in development. So as I mentioned, for this part of the presentation, I'm going to be creating a plugin in GitHub. And to do so, I just need to create a new repository. I'm going to call it UID demo. I'll just put in a description of the project. Remember, these will be consumed by other people, so it's best to be descriptive here. Once I create the repository, I can then go back to the project and I will commit my code and publish the project to GitHub. So here I'm just creating a README file, initializing my repository, adding all the files that we've created so far, committing that to the GitHub repository, creating my main branch, adding the remote origin, and then pushing the code to the repository. Now that the code has been pushed, last two steps are to add the Traefik plugin as a topic. This will allow Pilot to find the plugin in GitHub. And as the last step in publishing, I need to create a version tag. Once that tag is published, Pilot will find it in GitHub and you'll be able to see it in the plugin store. Now that the plugin has been uploaded to the plugin marketplace on Pilot, we can install the plugin from Pilot, from our source code that we committed to Git, and remove our development plugin. Now Pilot will give users instructions on how to configure and install the plugin, and check that out right now. If I click on install plugin, we can see the configuration example provided for any user to implement this into their Traefik installation. So now what I'm going to do is remove the development plugin completely. So there's just no question that we are not running that. So I remove the source directory that we built up. And I will implement the UID plugin configuration as provided by the Pilot marketplace. So by adding plugins and defining UID, I'm instructing my instance of Traefik to pull down this repository in this version. And within the rules file, I need to reference that plugin down here. So change dev to UID, because this UID references this plugin here in the Traefik configuration. Now that I have that configured, I can start Traefik. And if I go to local host port 8000 and who am I, we'll see that we get the header of X Traefik test and my unique ID being provided. So that wraps up the live demo portion of this presentation. If you have any questions, feel free to stick around and we'll answer those towards the end of the presentation. But for now, So what I've gone over today is I've shown you how it's now possible to extend the functionality of Traefik without requiring any sort of build pipeline, custom binaries, linked libraries, or anything else that typically would require a compiler. In addition to that, this capability, once it's matured, we will look at expanding this functionality into other areas of Traefik, such as the configuration providers or even load balancers. And finally, while we believe that code that is fed into the interpreter and runs without issue right now can be considered stable, there are many libraries that use unsafe syscalls and reflection to solve the problems that they're trying to address. And as of right now, we're working to ensure that these use cases can be supported in the future. So as of right now, it's still experimental. On the topic of plugins, we have a hackathon that starts on October 20th and runs through October 22nd of this year, 2020, where we're going to be giving away bounties and prizes for the creation of plugins. You can sign up with the link in the slide if you're interested, and we'll also be giving away t-shirts and stickers for those who actively participate. And participation can include anything from improving documentation, creating a plugin, fixing bugs, or submitting feature PRs. So the top link on this resource page, the plugins idea blog post, there's a lot of ideas in that post that can be implemented as a plugin. Some may be really easy and straightforward to implement. Some may be more complicated because of their dependency on third-party libraries that we may not support. The idea behind this plugin, though, is to just inspire people and give them a good idea of where they can start building their own plugins. Of course, we expect people to come to the hackathon with their own ideas, and those are equally as welcome as well. And we will, of course, issue bounties for anybody's plugin. It doesn't necessarily have to be one that's talked about in this blog post. You can sign up to the hackathon with this link on the page, and we have more information around the hackathon in the blog post. And of course, you can reach me on Twitter, not sure if Kevin, and GitHub as well. And of course, Traefik is there also.
All right, so thank you everybody for coming to this meetup. We've got a few questions that I do want to answer. If you have any questions, feel free to put them in the Q&A, and if we have time, I'll get to them. I have about 15 more minutes, and then we'll wrap up. So the first question is from Rafael, and he asked that, is it possible to not send a request towards the origin and just return a response based on your logic? And the answer to that is yes. And I do want to show you my browser. This is a plugin that I built for demonstration, just kind of try to figure out the plugin system initially. This is actually one that can be used legitimately. And what it does is it takes a list of IPs or like a CIDR block and will allow you to configure a block list, essentially a deny list of IPs that you don't want traffic to pass the request to the downstream service. So if we take a look at the code here, and in the serve HTTP method, we can see that if the request is blocked, then all it's going to do is return a header to the client saying it's forbidden, and then it's just going to abort. It's going to return, and the serve HTTP method won't be executed. And because of that, the serve HTTP is what eventually makes the call to the downstream service and then does the response. So if you abort before this method gets executed, then you're effectively not sending the request downstream. So hopefully that answers your question on that. It's just a matter of what you want to do with that request before you talk to the client. Like in most cases, you just want to return a forbidden status code or a 404 or what have you, and you can do that all through the header and the response writer. Like there's a bunch of different methods you can execute on that. Right, so Bogdan asked if it's possible to have any knowledge of what backend will be hit by the request in the middleware. I'm not sure. I know that you could inspect the properties of the request. Like you can actually, within the request, you can take a look at the request, HTTP request object. And within that, that's going to have headers and all the information that got past the traffic and which traffic used to determine which downstream service is going to eventually route to. But I don't know if that is like specifically anywhere within the scope of this plugin's execution. Like you would probably end up having to look at the request headers and figure that out yourself and create your own subset of rules within the plugin if you wanted to do something like that. That being said, I believe it's very well possible that you could theoretically expose the determination that Traefik made based on its rule match, because at this point, the middleware is being executed, so it knows which service that request is, ultimately what router it belongs to. So I don't see why you couldn't theoretically include that information in the context of literally the context that's being passed in the new. Again, I'm not entirely sure what is available in this context object. It very well could be possible that something is in there that will let you get to those details. But if I'll ask the team and see if that is at all possible, and if it's not, like what it would take to make it possible, because I certainly see that being useful for people implementing plugins. I've got a couple different questions about the availability of plugins being public and the option to make them private. So this is still considered an experimental feature. We initially released the plugin capability primarily to gauge interest, get people down the road of implementing well-known use cases with plugins. And we're investigating what the viability of having a private plugin system capability would look like, because we have to look at things like how do we support that? How do we ensure that the credentials to those private plugins stay protected, where those private plugins are hosted, and how they're accessed and how they're cached. There's a lot of questions that we have to answer around it before we make that functionality available. And so we're looking at all of our options there. But at the moment, there's no real concrete plans to make private plugins available at this moment. But again, we're looking at how we can best implement that and make it available in the future. So that's about as far as I can answer that right now. Hui Nguyen asked, can you suggest some ideas for building plugins? That's a great question. I actually just wrote a blog post. If you go to traefik.io/blog, I have a bunch of plugin ideas here that they're not my ideas. I didn't think of them. Y'all did, and you created issues in the Traefik repository asking for these plugins to be developed, and then that never happened. So I felt like these were some of the more popular ones, and the ones that seem to make the most sense to create a blog post with, if you will. So if you're looking for ideas for plugins to build, this is a great place to start. And we'd love it if you join us for the hackathon that's happening next week. And if you create a plugin, and it's not just a hello world type plugin, it's actually useful, you're eligible for a $100 gift card bounty. You just need to submit that you created that plugin during the hackathon. And we'll make all the forms and everything available for you to be able to do that during the event. Bogdan asked a great question. Since the plugin system is somehow running in a VM, it's not really a VM. I just use that as a term. I'm not even 100% technically sure of what the boundaries and how that is executing per se. That was just a fairly common concept that people can relate to. That being said, there is some overhead in terms of the interpreter. I know that based on the tests that the development team initially did. Now, what that overhead is, it just really depends upon the logic that you're executing in the plugin. So that being said, they did some base level tests with fairly common use cases, and they said that it added in the low I think in the single digit of milliseconds to the latency. And you know, of course there is some CPU overhead, and it was in the low, again, the low single digit percentages. So of course, anytime you execute additional logic within your proxy, you're going to suffer some kind of performance penalty. But you know, ultimately, if you need really raw speed in your proxy, you probably, if you're at that point, you probably are able to implement a plugin as a package natively and avoid that performance hit by using something like an interpreter to execute the plugin. Right. So another question from Manfred: does a plugin have a representation in Traefik dashboard, such as its configuration, like the header name that you used, its existence of even some custom status message? So, well, let's take a look, because that's a great question, and I want to make sure I give you the right answer. So I'm going to start up my Traefik instance and take a look at the dashboard. I think it's on port 8080. I can't remember. Yeah, there it is. All right, so I have some routers here. I have the who am I. So it looks like, even though I do have a middleware on this, because if I go to localhost 8000, I hope if I do who am I, we can see that I've got the UUID thing here. But it looks like the middleware, it's undefined here. And I'm guessing it's because it's a separate middleware system. It's the plugin system that it's not showing up there. So wait, well, there's one here. So it looks like we could probably do, I'm not sure what would be required to pull in the configuration and do some other more reflective type details on that, but it's certainly worth raising an issue in the repository and in the Traefik repository, because it just seems like it would make sense that that information would be here. Now, I guess another question would be is like if this were a package middleware, like one that came in Traefik, if that configuration shows up here or not, because I know that there, in some instances, you wouldn't want that in the UI because you're like, let's say you're using something like an HTTP auth middleware. You don't want to put your password in here, right? So I don't know what the viability of that is based on, you know, how sensitive the information is that you're passing in a configuration. So hopefully that answers your question. Okay. Well, I appreciate all the questions y'all gave me. They were great. Y'all gave me a bunch of them. So if there are no more questions, we'll go ahead and wrap this up. Got a few more minutes, so I'll wait like 20 seconds for another question if anybody has one. And if not, I will wrap this up. And I look forward to seeing y'all next week at the Hackathon. All right. So thank you all again for taking the time to come to this meetup and listen to my talk about plugins. I hope you learned something. If you have any questions or any comments, feel free to drop me a line on Twitter. If for our ambassadors, drop a line in our Discord channel. I look forward to hearing from you. Thanks again, everyone. Have a great day.